sp3d2 hybridization. The example is another superoctet or hypervalent molecule, that is sulfur hexafluoride or SF6 molecule. It's obvious that sulfur is the central atom and all fluorides or fluorine is the surrounding atom. There would be 6 sulfur fluorine bonds. So first of all we will find the valence shell, ground state configuration, of sulfur. Sulfur is 16, that is configuration 1s2, 2s2, 2p6, 3s2, 3p4. So it has a configuration of valence shell 3s2, 3p4 and 3d0. The orbital diagrams are like this. As per Hund's rule, and 3d0. Now as sulfur has to form 6 covalent bonds through mutual sharing of electrons, it's evident that the sulfur needs 6 half-filled orbitals. In ground state it is only having 2 half-filled orbitals. So in one excited state, one of the p electron would migrate to D, and in the second excited state the s electron would migrate to D. So the first excited state valence shell, configuration of sulfur would be 3s2, 3p3 and 3d1. The s electron would remain unaffected, but one of the p would migrate to D. In the second excited state, three s1, 3p3 and 3d2, one of the s electron would migrate to D. Now in this we have 6 half-filled orbitals. This all together will go for a hybridization, that is sp3d2 hybridization of sulfur. We will have 6 degenerate orbitals. Each one is known as sp3d2, and the 3d such vacant orbital, pure orbitals, would remain over there unfilled, while this will be singly filled up. In the next step we will have bond formation with 6 fluorine atoms, this is the orbitals of sulfur, and this is with shared contribution of each fluorine, thereby such 6 fluorines would be there. The shape is octahedral. In fact, the previous one we have seen trigonal bipyramid, means consider this as a triangle, equilateral triangle. One will be above the plane, another will be below the plane. Here it will be a square bipyramid where sulfur is at the middle of the square and all 4 vertices of the square are being occupied by 4 fluorines. This is how the square is being made. This is all in the plane, and one fluorine is necessarily above the plane, another fluorine is below the plane. But the thing is, since the diagonals of a square bisects at 90 degree, this angle is also equal to 90, and above and below the plane the angles are also equal to 90. So in spite they have the 3-dimensional structure, the bond angle is only 90. This is how the SF6 molecule is being formed. 3D3 hybridization. An example would be iodine heptafluoride, IF7 molecule. Such molecules are also known as interhalogen compounds made up of 2 halogens. Iodine 53 has a last shell configuration 5s2, 5p5, 5d0. So in valence shell configuration, of iodine, of course in ground state, would be 5s2, 5p5 and 5d0. Since 7 covalent bonds has to be formed between one iodine and 7 fluorine, we require 7 half-filled orbital. Presently in ground state it is having only one half-filled. So in excited state this migrates over here, this also will migrate over here, and in the second excited state 5s2, one of the electron of 5s2 will migrate to 5d. So therefore in first excited state configuration, five is 2, 5p3, 5d2. One of the two electrons from P would migrate to D. And in the second excited state, valence shell configuration of I will be 5 is 1, 5p3 and 5d also 3. This gives the 7 half-filled orbitals and it is intermixing of sp3d3 orbitals. So the hybridization will be sp3d3, that of iodine, and 7 such hybrid orbitals are formed. 2, 3, 4, 5, 6, 7. Each one is named as sp3d3 with single electrons of iodine, and the two 5d pure orbitals would remain vacant. In the next step, bond formation with 7 iodine fluorine molecule. These are the 7 sp3d3 species. Single electrons of iodine. This is how the central atom iodine is ready, and these are the electrons for mutual sharing by 7 fluorine. The shape is pentagonal bipyramid, which comes as the phosphorus is at the centroid of a regular pentagon, it's a regular pentagon, now in this regular pentagon, above the plane and below the plane, this could be done like this. One is above the plane, another is below the plane. The two, F molecule will be there, IF. IF7, it is not chlorine, it will be fluorine. And the bond angle within this, see, this hole is 360, within this 5 equivalent distance are there, so each bond angle will be 72 within the plane, and above and below the plane or perpendicular to the plane will be 90. Therefore the bond angles are 72 degree and 90 degree. It's again obvious that the bonds are not equivalent, and the two axial fluorine could readily be dissociated, and hence it readily undergoes this reaction. It is exactly same reason that is explained in case of phosphorus pentachloride. This is how the superoctet, hypervalent or electron deficient species are being explained through hybridization.